All right, so this is page 151, and we're continuing in section 7, topic 5. This is not new, this is just a continuation because the first video we couldn't get everything covered. So we are on step 3 from that first example that we were graphing. And step 3 is where you find the vertical asymptotes. Which sometimes I abbreviate as just VA if you see that. And to find the vertical asymptotes, you have to take your problem once you've factored it, which was y equals x plus 4 times x minus 3 divided by the quantity of x plus 2 times x minus 2. And it's easiest if every time you do this, you look back at your notes, read everything, all right? Instead of just saying, I don't get this, go back and look at your notes. I have to look at my notes several times every year that I teach this to remember, oh, what do I do step by step by step? And then once I've looked at it a couple times, I'm like, oh yeah, I got this. But until then, I read the notes for every single step, every single time, okay? So if you go back and look at step 3, which was on page 147 of your notes, it says, find any vertical asymptotes. Graphs of rational functions can have an unlimited number of vertical asymptotes. And I would show this on the screen, but I still have people copying for those of you at home. To find vertical asymptotes, make sure the numerator and denominator are factored completely, which we already did that in step 1. Everything's factored. Cancel any common factors. Do I have any factors that can be canceled? Yeah. I know, but I'm just letting them know that I would show it up here, but I still have people copying, so, you know, that's why I wasn't. Cancel any common factors. We don't have any factors that can be canceled, okay? So the next thing says, if no factors can be canceled, which that's us, then the vertical asymptote has the same equation as the restriction. This is referred to as non-removable discontinuity. I can show it now, okay? So I don't even have to read on because I found what goes with my situation here because we can't factor anything. So what it means by the restriction, that means what's going to turn my denominator into a 0. Okay, what number would, if I plugged into x plus 2, what would make that turn into a 0? If x was negative 2. And what would it be here? 2. So if you're not sure, all you have to do is, we'll say, find the restrictions. And this will tell you the equation or equations of the vertical asymptote, or VA. So to do that, take your denominator only in factored form and set each factor equal to 0. And then just solve for x. Oh, I forgot to tell you also on the walkout, If you choose not to and you want to stay in your classroom, that's fine. Your teacher will stay in there as well. Okay, so if you don't want to, you can stay in the class. You don't have to participate if you don't want to. We go if our whole class goes. Then we can go. But if everybody doesn't go, then we're responsible for those in our room, so we have to stay. We gotta stay. Okay, so in a minute I'm gonna draw the graph and we're gonna start plotting some of this stuff. After we find to see if there's any horizontal or oblique asymptotes. So this is confusing because you're like, wait, I thought x couldn't be -2 or +2. Well, you're right, it can't, because you're going to have asymptotes that go through these points, and your graph can't touch an asymptote, so it won't equal these points. Your vertical asymptotes are the same as what like if we had an extraneous solution, that would be the same equation as your vertical asymptotes, okay? So we just call them restrictions. If it says state the restrictions, you're saying what, if you had an extraneous solution, what would it be? All right. Step 4. If you look on page 148, step 4 said determine if you have any horizontal asymptote. The graph of a rational function can have no more than one horizontal asymptote. So for step 4, we know we need to find the horizontal asymptote. So, well, how do you do that? Well, let's go back to step 4. Step 4 says, if the degree of the numerator is less than the degree of the denominator, then the graph has a horizontal asymptote at y = 0. So that's the same as the x-axis, and we could sketch that. So this is about degrees. So let's go back and look and see how many degrees we have. When our problem was in standard form, how many degrees did the numerator have? 2. How many did the denominator have? 2. So our degrees in the top and the bottom, the numerator and the denominator, they're equal, right? So this first arrow said if the numerator is less than the denominator. So that one's not us. The next one says if the degree of the numerator is greater than the degree of the denominator. That one does not apply to this. The third arrow says if the degree of the numerator is equal to the degree of the denominator. So that's the one we want to look at. Then the graph has a horizontal asymptote. Remember, horizontal goes this way. At y = a divided by b, where a is the numerator's leading coefficient and b is the denominator's leading coefficient. So that's different than when you have a quadratic and you're looking at a, b, and c, okay? They're telling you that a is the leading coefficient, get this down here, of the numerator. So our leading coefficient would be 1, right? And the leading coefficient of the denominator, coefficient, is 1. So basically y = a divided by b, in this case would be y = 1 divided by 1, which is just what? 1. So we'll have a horizontal line that goes through the y-axis at +1. We just have one of those. And I wrote over here, I just put a little star and said the degrees in the numerator are equal to the degrees in the denominator. That's why y equals a divided by b. So step 5 says, determine if you have an oblique or slant asymptote. This only occurs in rational functions when the degree of the numerator is 1 degree greater than the degree of the denominator. Well, our degrees were equal, right? So if they're equal, we can't have an oblique asymptote or a slant asymptote. Two words mean the same thing. So step 5, there is not an oblique, or if you want to call it slant, asymptote. So now we have all of the information we need to graph. Well, we think we have all of the information. We might have to find some extra ordered pairs if our graph doesn't give enough information once we plot everything that we know. We just have to go ahead and plot what we found and then go from there. Okay?
Step 5, right?
That's, oh yeah, sorry, step 5. So I'm going to go ahead and sketch my X and Y axis. And I'm going to go back to step 1 and look back and see the things that I found for my graph. Step 1, we had to find the x-intercepts. And if you go back and look, we found that our x-intercepts are -4 and +3. So I'll plot those points on my x-axis. Step 2, I found that we had only one y-intercept, and it was at +3. So on the y-axis, I will plot a point at +3. On step 3, we found that we had vertical asymptotes at x equals -2 and x equals +2. So vertical asymptote, remember we're going to do a dash line, bless you, at x equals -2 and at x equals +2. An asymptote is a line that your graph will approach but will not intersect. It just runs along the asymptote, kind of hugs it. In step 4, we found that we had a horizontal asymptote at y equals +1. So we'll draw a horizontal line through the y-axis at +1. Okay, so Rational equations, the graphs are kind of crazy, and they're always different. Okay, they're not all the same like a line or a parabola that always has the same shape. So these asymptotes have divided the graph into several regions. Now remember, these are functions. These are rational functions. And to be a function, you have to be able to pass the vertical line test. Sometimes you call it the pencil test. And remember, to pass the vertical line test, that means if you place a vertical line anywhere on the graph, in order to be a function, it can only touch that vertical line one time. So if I have a graph in this lower region here, then I cannot also have a graph up here. Because if I did, you'll have to visualize this. If I did, it wouldn't pass the vertical line test, okay? So if I have a part of a graph down here, I know I can't have one up here. I could have one next to it or over here, but it has to be able to pass the vertical line test to be a function, all right? So these asymptotes have divided my graph into like 1, 2, 3, 4, 5, 6 different regions. So those x and y intercepts are going to help us know where the graph is. Sometimes, and sometimes they're all in the same region, so we have to do more work. In this case, we're not going to have to do more work because this x-intercept right here, it tells me where my graph is. And I know I can be, if I want to be more specific, I can find more ordered pairs. But it's not necessary because this is just a sketch. And I know my graph is going to hug those asymptotes. And there can't be anything up here because it wouldn't be a function. It wouldn't pass the vertical line test. Okay? In this middle region, which is also, we have like this upper part and this lower part, my y-intercept fell in that upper part, so that means I won't have any part of my graph down here below it. So it's just going to hug the asymptotes. And I know it's going to open up because if it opened down, it would run right into that asymptote. Okay? And while my graph looks like it's going straight up, it's just getting closer and closer and closer and closer and closer and closer to the asymptotes as it goes, just little by little by little by little by little. It just looks like it's going straight up. What's that?
Does it touch it up?
It was never going to touch. It's going to keep getting closer and closer and closer and closer and closer. It's never going to touch it.
Infinitely?
That's what they say. I can't prove it because, you know, my graph paper's not that big. Just put that in a basket under your desk, please. Thank you. Okay, on the right side here, if I did not have any points in either location, I would have to choose an x value that fell in these regions and substitute it into the problem and find a y. Or just put it in a cabinet, maybe. But since I do have another x-intercept over here and it's in that lower region, I know where my graph is. Okay, in the next one, it's not going to be that easy. We're going to have to find some other ordered pairs. But it's nice when you have an ordered pair in each region so you don't have to do more work to find other points. And there you have it. At no point on this graph will you have an x value that's net positive 2 or negative 2. So your domain basically is all real numbers except for positive 2 and negative 2. Your range, you will not have any y values that equal positive 1 because there's an asymptote there. So your range would be all real numbers except for positive 1. Okay? Cannot have any ordered pairs on the asymptote. And that's that. I've got 2 more examples for you. So I'm going to have to speed it up a little. Page 152. Graph y equals x plus 4 divided by the quantity of x minus 4. X plus 4 divided by the quantity of x minus 4. Do you have any thing that can factor? I know my grammar was not correct there. My numerator, it's linear, it's not factorable, right? There's not a GCF. My denominator is linear, there's no GCF, it's not factorable. They're not quadratics, they're not difference of squares, anything special. So I can't factor there. I can't factor anything. So yay, we'll just move on. I'm just going to make myself a little note. There is nothing that can be factored. I just go ahead and get that out of the way because when you're finding asymptotes down the road and you want to see if anything cancels, I think it's horizontal asymptotes, you have to have it factored at that point. So it's just go ahead and do it now. So step 1, if you go back and look at your notes, it says find the x-intercepts. So if you want to know where your graph crosses the x-axis, you substitute in a 0 for y and solve for x. So that's what I did over here in this step. Where I saw y, I substituted in a 0. This is a rational function because we have a fraction and there's a variable in the denominator. So remember, to solve those, you want to multiply every term by the least common denominator. Y'all did this a lot when the sub was not here. So what is my least common denominator? X minus 4. So I'll multiply both terms by x minus 4. What's x minus 4 times 0 going to be? 0. What's over here, x minus 4 and x minus 4, those will cancel, right? And basically I'll just left with x plus 4. So now to solve for x, I'll just subtract 4 from both sides. And that tells me that x equals negative 4. That is my x-intercept. And you know what? I'm going to go ahead and sketch a graph in now so I don't run out of room. I can just work around it. So my x-intercept is on the x-axis, obviously, at negative 4. So this time I only have one x-intercept. Step 2, I have to find the y-intercepts. Intercept or intercepts. So to find y-intercepts, we substitute a 0 for x and solve for y. So I went ahead and did that. So in my numerator I have 0 plus 4, which gives me positive 4. Denominator 0 minus 4 is negative 4. And I can simplify that. What's positive 4 divided by negative 4? -1. Now, I'm not finding asymptotes here. I'm not drawing a horizontal line at -1. I'm just found the intercept. So on my y-axis, when y is -1, I will plot a point there. Step number 3, find vertical asymptote or asymptotes. So to find your vertical asymptotes, you go back and you look at step 3 in your notes, and you recall that you can have an unlimited number of vertical asymptotes. To find vertical asymptotes, make sure the numerator and denominator are completely factored. We did that to start with. Cancel any common factors. Did we have any common factors? No, I can't cancel the x's. I can't cancel the 4's. A binomial can only be, you can only reduce it with another binomial that's identical. You can't take out parts like you can a monomial, okay? So we don't have anything that can be canceled. So it says if no factors can be canceled, that applies to this problem, then the vertical asymptote has the same equation as the restriction. Remember, your restriction is where you take your factored denominator, set it equal to 0, and solve for x. It's the same thing as if we were doing a rational equation and we wanted to know if our answer was extraneous. We would look up here and say, what would x need to be to turn the denominator into 0? It'd be a +4. Well, that's the same thing as what your vertical asymptote is going to be, a vertical line that goes through +4 on the x-axis. So vertical asymptote is up and down. It goes through +4. So 1, 2, 3, 4. Go ahead and sketch that in. Just do a dashed line. I know my y-axis is a little curvy. Do we have any questions? I know I'm going through this one kind of fast because of time. Step 4. This is when we find the horizontal asymptote, if there is one. I'm just going to go with HA because I'm running out of room. Horizontal asymptote. If you go back and look at your notes on page 148, it says determine if you have a horizontal asymptote. The graph of a rational function can have no more than one horizontal asymptote. You may not have any, but one's the max that you can have. So 1 or 0. This is where we look at degrees. So before we even read our directions, how many degrees does our numerator have? 1. How many does the denominator have? 1. So they're equal, right? It's going to be like the last time. So if they're equal, that was the third arrow. If the degree of the numerator is equal to the degree of the denominator, then the graph has a horizontal asymptote at y equals a divided by b, where a is the numerator's leading coefficient and b is the denominator's leading coefficient. Okay, so it's y equals a divided by b, where a is the numerator's leading coefficient. So what's the leading coefficient of the numerator? Y'all know what the leading term is, right? It's 1. Well, the leading term is this 1x, because that has the highest degree. So the coefficient's 1. And the denominator, what's the leading coefficient? It's 1 also, right? This is my leading term because it has the highest degree. The coefficient is 1. It's implied if it's not there. So just like on the last example, 1 divided by 1 is just 1. That's our horizontal asymptote. So on the y-axis, horizontal. Asymptote through positive 1. Step 5, if you have a horizontal asymptote, you're not going to have a slant asymptote. Because horizontal or slant asymptote, you have to have when the degree of the numerator is 1 degree greater than the degree of the denominator. Well, these were equal, so there is no slant, or if you want to call it oblique asymptote.
You can write step 5 again.
What's that?
You can write step 5 again.
I don't know why I do that. Step 5. So this time, if you look at our graph, the asymptotes separated it into 4 regions, right? We have here, 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 and here. The only 2 points that we know fall in the same region. So, well, that's cool for that region. We can go ahead and we know it's going to hug the asymptotes. So we can do a sketch of that. We know if it's a function, we cannot also have another part of the graph directly above it, because if we put our vertical line on there, it would not pass the horizontal or the vertical line test, right? So we know we're not going to have one up here. We don't have to worry about that. However, to the right of this vertical asymptote, you're probably going to have a graph either in the upper or the lower region, one or the other, not both, or it wouldn't be a function. So we got to figure out, you can just make a guess. But if this was my ACT test and I really needed a 27 to go to the college of my dreams, I'm not going to be willing to take a guess. I'm going to take the time to figure out where exactly is my graph, right? So, in this region, every part of the graph in that region has an x value greater than 4, correct? So if we substitute a value in for x, we either want it to be 5, 6, 7, 8, all the way up to positive infinity, wherever you want. And that's going to tell you where your graph's going to be. So this is 4 right here. I'd probably just go with when x is 5, what is y? Okay? And you just need to substitute that into your original function in factored form or standard form. It doesn't matter. I'm going to call it a test point. Make a little table of values, and I'm going to say when x is 5, what is y? Everything less than 5, all of those x values, we already know where those graphs are. So I'm running out of room, so I'm not going to write the original as y equals x plus 4 divided by x minus 4. I'm going to write, instead of x plus 4, I'll write 5 plus 4 divided by, instead of x minus 4, I'll write 5 minus 4. So that's y equals 9 divided by 1, or y equals 9. So the ordered pair we found is when x is 5, y is 9. 5, 9. Okay, so I'm going to plot that point up here on my graph. When x is 5, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of high up here. Doesn't matter. It just lets us know where that graph's going to be. So if it's in that upper region, it can't be in that lower region, again, because that would not be a function. Does anybody have questions on that? Okay, page 153. This is the last one. Hopefully the sound turns out on this video, and I will post it on Edmodo if you need to go back and rewatch it. If there's something that you missed, if you need a better explanation, or not better because it's going to be the same, but if you need to hear it again. All right, we're going to graph f of x equals x squared minus x divided by the quantity of x plus 1. First thing I'm going to do is factor the numerator and denominator if possible, or if anything is possible. Can I factor that numerator? It has a what? Well, it's squared, so it's quadratic, but it also has a not difference of squares, because x squared square and its difference, but is this x a perfect square? Right. It does have a GCF of what? Of x. So I can factor out, and I'm going to go ahead and change f of x to y. Okay, we don't have to, but I am, because I'm going to be finding the x-intercept, and I'll put y, 0 in for y. So I know the GCF is x, and if you factor out an x, what's left when you divide it out of each term? X minus 1. Good. The denominator, can x plus 1 be factored? No. And you can put it in parentheses. You don't have to. I like to, because sometimes kids, they still want to cancel out like this x and this x. This is a binomial. It goes together. So it can only cancel with another binomial that's identical to it. Can I reduce x minus 1 and x plus 1? No, they're not identical. Okay? I can only reduce x minus 1 with x minus 1. X plus 1 with x plus 1. One's got to be in the numerator, one in the denominator. Everybody cool with that? Step 1, find the x-intercept. I'm going to do some abbreviating because it is 8:20 and we got to finish before the bell rings, and I got to give you your homework. So remember, to find the x-intercept, you substitute in a 0 for y. So I'll just go ahead and turn that y into a 0. I'm not going to write my original problem. And to solve for x, I've got x's in the numerator, x's in the denominator. I want to clear the fraction. That's what we do when we solve rational equations. So we need to multiply each term by the LCD, which is what? X plus 1. On the right, x plus 1 and x plus 1 reduce. On the left, what's x plus 1 times 0? 0 equals, on the left, we're just left with x times x minus 1. Now, a lot of students at this point, they want to distribute, and I understand, because usually that's what you're doing, but we're trying to solve for x. So if this is already factored, don't turn it back into standard form, because if I want to solve for x and it's factored, you just set each factor equal to 0 and solve for x, right? So here, my factor was x. Can x equal 0? Yeah. If my GCF was 2, and I set 2 equal to 0, can 2 equal 0? No. So 2 would be a factor, but it wouldn't be a solution, right? If it's a variable, then x equals 0. Over here, add 1 to both sides, and x equals positive 1. I'm going to go ahead and sketch my graph. And I'll just add on to it as we find different pieces of information. Bless you. So on the x-axis, my y-intercept is 0 and positive 1. Step 2, I want to find the y-intercept. So remember, to do that, if you want to know where your graph crosses the y-axis, every ordered pair on the y-axis has an x value of 0. So we substitute in a 0 for x, solve for y. In my numerator, what is 0 times 0 minus 1? 0. In the denominator, 0 plus 1 is 1. Okay, this is when we get nervous. What is 0 divided by 1? Yes, 0. What is 1 divided by 0? What do we call it? Undefined. Undefined. If 0's in the numerator, that's fine. It reduces to 0, unless, of course, 0's in the numerator and the denominator. But if 0's in the denominator, you can't divide by 0, so you would just say undefined, okay? But 0 divided by 1 is 0. That was my x-intercept. It's also my y-intercept, so we already have that point. It really didn't help us, sadly. All right, well, let's find some intercepts. I mean, not intercepts. What are they called? Asymptotes. Step 3, we're going to find the vertical asymptote, also known as the VA. To do that, you want to look at your restrictions. So I'm going to rewrite my problem that was in factored form, and I'll cancel out any factors that I can. Do I have any factors that will cancel? No, nothing cancels. So to find my vertical asymptote, you just set the denominator equal to 0 and solve for x. When you're doing that, you're actually finding the restriction, and your restriction has the same equation as your vertical asymptote. So I know I've said that before, but I don't know how completely we wrote it down, so I just wanted to make sure you had that somewhere in your notes. So I said find the restriction, set denominator equal to 0 and solve. This is the restriction and also the equation of the vertical asymptote. Numerator, you don't set anything in the numerator equal to 0 when you're finding the restriction, just the denominator. So I will go ahead and sketch the vertical asymptote at x equals -1. Step 4, I have to find the horizontal asymptote. And remember, the horizontal asymptote is where you look at the degrees compared to the numerator compared to the denominator. How many degrees are in our numerator? 2. How many are in the denominator? 1. So if we go back and look at the steps for horizontal asymptote, page 148, determine if you have a horizontal asymptote. The graph of a rational function can have no more than one horizontal asymptote. The first arrow said if the degree of the numerator is less than the degree of the denominator. That does not apply to this problem. The second arrow says if the degree of the numerator is greater than the degree of the denominator, that's us, right? The numerator is greater than the denominator. Then the graph has no horizontal asymptote. It says nothing needs to be sketched in this case. But then we put a little star and said, if you don't have a horizontal asymptote, check to see if you have an oblique or slant asymptote in step 5. So we don't have a horizontal asymptote. We need to check to see if we have an oblique asymptote, which is step 5, and I'm going to remember to put the 5 this time. So step 5 is on page 149 of our notes. It says, determine if you have an oblique/slant asymptote. This only occurs in rational functions when the degree of the numerator is 1 degree greater than the degree of the denominator. Was that true in this case? Is our numerator 1 degree greater than the denominator? Yes. So we're going to have a slant asymptote. We got to figure out how to find it. If so, use long division to find the quotient. This will give you the equation of the oblique asymptote. Ignore any possible remainder. Well, in this case, we'll actually be able to do synthetic division because the divisor is linear, okay? So y'all remember how to do division. And I'm missing the constant, so I'm just going to throw a 0 down. You can still do long division if you want to. Synthetic division, remember that divisor, whatever the constant is, I changed the sign, I put it behind the little house. Bring down all of your coefficients and the constant. Skip a line, draw a line. That first number, I'm just going to bring it down. What's 1 times negative 1? Negative 1. Negative 1 minus 1 is negative 2. Negative 2 times negative 1? Positive 2. 0 plus 2? 2. So we have, remember, you go 1 degree less than the dividend. So this has 2 degrees. We'll start with 1 degree, 0 degrees, and anything less is our remainder. It said the quotient will give us our equation, and it's linear, okay? So if you want to think about it as y equals, it's going to be x minus 2, and it said ignore any remainder. So that is the equation of the line. It's not vertical, it's not horizontal. It's just a regular old line. So just as a review, if this is my line, what is the y-intercept? Negative 2. And what's the slope? Not x. 1. It's the coefficient of x, right? So the slope, we call that m. It's just positive 1. Rise of 1, run of 1, and it's a positive line. This is Algebra 1, so I'm not going to do much review on it. We graph lines for like a year. But when you're graphing a line, you start at the y-intercept, which is negative 2. This is the y-intercept for the line, not for the whole thing, okay? The slope is positive 1. So if I go up 1 to be positive, do I go left or right?
Right.
Right. If I go down 1, I would go left 1. So that's a slant asymptote or an oblique. You've got vertical, horizontal, and then if it's slant or oblique, it's going to be any other line that's not vertical or horizontal. So this graph has 4 regions. We've got here, 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 and here. Unfortunately, the 2 points that we know both lie in the same region. So that kind of stinks, but it's okay. We're just going to have to do a little bit more math. We know we're not going to have a graph right below where I just graphed that blue because it wouldn't be a function. But I'm probably going to have one over here to the left of that vertical asymptote. I just don't know if it's going to be above or below. Okay? So kids still get confused. Well, how do you know what x to pick? Well, what are the x values that lie to the left of that vertical asymptote? We know this is negative 1, so any x value less than negative 1. Negative 2, negative 3, negative 4, negative 5. What ifs? I'm going to do my little, I'm kind of running out of room, so I'm going to do my little test point up here. You just pick wherever you have. So I'll just choose when x is negative 2. And I'm going to put it into factored form. You could do factored or standard. So wherever I saw an x, I substituted in -2. So that gives me -2 times -3 divided by -2 plus 1 is -1. -2 times -3 is +6 divided by -1. And what is +6 divided by -1? Y'all know? What's 6 divided by 1? 6. What's a positive divided by a negative? Negative, so it's -6. So my ordered pair is -2, comma -6. So that is down there in the lower region. And you got to be careful, especially on a hand-drawn graph where you don't have graph paper, because that's kind of close to the other region. So you kind of want to be careful, make sure that you're graphing it in the right spot. Location. Is everybody cool with that? You have one example to graph. If you're about to leave for Summerlin, you need to get your little pencil ready. Otherwise, it will be on Edmodo. Okay, so you'll have to make sure you check. But I'm going to go ahead and put this up here. If you need to borrow my book, you can.
Students and teachers, please pardon the interruption. I wanted to share, students, that today across the nation, students have planned a walkout as a memorial to the 17th